So today, we're going to dive into something a little different. We're not just exploring a complex math topic, we're exploring a pretty radical way to learn it. This is all about dynamic topology, learning by doing, an idea that basically takes the traditional classroom and flips it right on its head. Especially for a field like topology, which, you can think of as studying shapes, but in a super flexible, almost rubber sheet kind of way.
Okay, so let's start with a really basic question. Just think for a second about the last time you tried to learn something genuinely hard, maybe a new language or a piece of software, whatever. How do you get from just hearing about it to actually truly knowing it? How do you make a complicated idea feel like it's your own?
For pretty much all of us, school looks a lot like the column on the left. Passive learning. You know the drill. You sit in a lecture, you listen, you take some notes. It's what we're used to. But what if there's a better, more powerful way? The active approach on the right suggests that instead of just absorbing information, you should be the one building the arguments from the ground up.
And that brings us to the guy behind this whole idea, Gordon Wyburn, and his totally maverick method for teaching one of the most abstract parts of math there is.
I want you to picture this. It's 1937. A handful of students sign up for a topology class, and their professor, Wyburn, has this incredibly bold goal. He doesn't just want to teach them the material, he wants to turn them into actual researchers, and he wants to do it as fast as possible. This quote from one of his students, John L. Kelly, shows you just how upside down this class was. I mean, think about that. It wasn't a lecture course. The professor just gave them the raw materials, the definitions, the big ideas, the theorems, and then it was up to the students to do all the heavy lifting, to actually build the proof. And the rules were so simple, but man, were they demanding. Rule 1, you had to work all by yourself. Rule 2, no looking up the answers in textbooks or papers. And Rule 3, you had to get up in front of the whole class and present your own original proofs. See, this was never about finding a known answer. It was about inventing the path to get there yourself.
And this next quote from Kelly really gives you a feel for what Wyburn was like as a teacher. He remembered this just incredible patience. I mean, sure, it was a high-pressure environment, no doubt, but it was also really supportive. The point wasn't to be perfect. The point was the struggle, the attempt, the whole messy process of thinking like a real mathematician.
So, did this whole crazy experiment work? Well, Kelly pointed out 3 huge advantages. First, the students were completely 100% involved. You couldn't just sit back. Second, when you build an argument yourself, it just sticks in your brain, it's basically unforgettable. And third, and this is the big one, it gave them the confidence to not just solve problems, but to actually create new mathematics.
In the end, it all just boils down to this really simple, powerful idea. Doing something is just way more fun, way more engaging than just watching someone else do it. It's the difference between being a fan in the bleachers and a player on the field.
So how did this revolutionary classroom experience get saved from just being a cool story? Well, it was captured and preserved in a very, very unusual book.
The book, which is called Dynamic Topology, isn't meant to be just, read. It's a direct copy of the course itself. The whole thing is structured to put you, the reader, in the driver's seat as the active mathematician.
So here's a taste of how it works. The book gives you a definition, like a fundamental building block. For instance, a connected set. Now, don't worry if the language sounds a bit dense. The key idea here is that the book gives you a very precise tool, a solid place to start.
And then, bam, immediately, it's your turn. The book throws a theorem at you and basically says, okay, you have the tool, now go prove this. This isn't some review question at the end of a chapter. This is the chapter. This is the work.
And the real genius of the method is the pacing. It's brilliant. The book starts you off with smaller, kind of guided steps. But as you go, it expects more from you. It slowly, gradually takes the training wheels off, forcing you to invent the smaller, in-between steps all by yourself.
Okay, so we've talked a lot about the how, this active, do-it-yourself method. But what about the what? What is the actual subject of dynamic topology anyway?
In the back of the book, Wyburn himself tells us, it's not just about studying static shapes. It's about what happens when you introduce action, when you have functions and mappings. It's about the transformations, the dynamics of these spaces. The learning method is dynamic, and so is the subject. It forces you to act on the math, which is just the perfect way to understand a subject that's all about the actions of functions on spaces. It just fits perfectly.
And all of this brings us to the final, really crucial takeaway from this whole approach.
It's not just a cool story, it's a challenge to anyone who really wants to learn something.
Kelly just sums it up so perfectly here. When you reconstruct a proof, it's not just some homework exercise. It's an act of hope. It's like you're training for the day when you might create something totally new yourself.
So as we wrap this up, remember this. The ultimate goal of the Wyburn method, and the book that came out of it, is something so much deeper than just passing a test.
It's about learning how to create it. It's about making that huge shift from being a student of a subject to being a practitioner, a creator, a mathematician in your own right.
And that leaves us with a question that goes way, way beyond topology. In anything you truly want to master, what will you discover about the subject and about yourself when you finally stop just listening and you start doing?